Welcome to another video. We are continuing solving textbook problems. The textbook is Stewart Calculus Early Transcendentals, the 7th edition. We're on section 7.5, techniques of or strategies for testing integration, or whatever that section is called. I don't even remember. Okay, this is the one where there's lots of integrals. You just give it a random integral per se, and you have to know which technique to use, or you have to try different techniques to solve it. Okay, so we left off on number 41. Let's continue. We have integral theta, tangent squared theta, d theta. So let's go down a list of techniques. Substitution, I don't see something obvious to substitute here. So let's hold off on that. Maybe we can, but I don't see a nice substitution. So let's not do that. Let's keep it in the back of our mind. By parts, I do see a product of two things. Maybe we can do by parts, so let's also keep that in the back of our mind. It's not a simple trig integral because we have a theta here, so it's not like tangent and secant, so not like one of those techniques that we learned. Trig sub, I don't see like a something squared plus something squared, probably not that. Not a rational function for sure, so not partial fraction decomposition. So what should we do? Well, if I do by parts, if u is tangent squared, then du would be 2 tangent theta times secant squared theta d theta, which isn't quite nice. So I kind of don't want to do that. And if I set my dv as tangent squared, how do I get the integral of that? Well, I can change tangent in terms of secant squared minus 1. That's fine, but that seems tedious. So maybe let me just change. So that might be doable. But let me just change the tangent squared in terms of secant first. Maybe that will make my life a little bit easier. But as I said, you could probably just set dv as tangent squared directly, and then find v by integrating that tangent squared. Okay, anyway, so I was saying, let me change tangent squared to be secant squared theta minus 1. Okay. So now I need the integral of, let me distribute the theta. So it'll be theta secant squared theta minus theta d theta. So I can even break this up into theta secant squared theta d theta minus integral theta d theta. This one's very easy. This one, maybe it'll be a nice integration by parts. So let me do it on the side over here. So let me call it x instead of theta. So x secant squared x dx. So let's maybe let our u be x, because dv, if we set it to be secant squared, v is a nice antiderivative, just tangent. I've got dx up there. du would be dx. Okay, so this one would equal x tangent x uv minus integral v du, so minus integral tangent x dx. Now this one I know how to solve, or if you remember it, even better, is ln of secant x plus c. Okay, so I found this integral. This integral is just power rule, so let's combine the two then. Okay, so here, so I have x here. This was in terms of theta. Let's write it as theta instead. So theta tangent theta minus ln of secant theta. Okay, so I adjust this one. How about this one? This will be minus half theta squared, and then I need my plus c, and that's my answer. Okay, so this one was not too bad at all. So again, you could probably just do integration by parts directly from here. You would just have to find the integral of, you'll set u as theta and dv as tangent squared. dv is tangent squared, so then you have to find v, which is the integral of tangent squared, which you'll probably need to change to secant squared minus 1 also. So again, that's probably doable, but I just decided to do it like this. This was more intuitive to me, at least. Okay, next, 42. Integral arctan x over x squared dx. Okay, so it's another product of two things. So maybe we can try integration by parts. And I know that to find the integral of just arctan x, I need integration by parts in itself. So maybe let's try that. So let's u be arctan x. Oops, sorry, that doesn't look Very nice. Du would be 1 over 1 plus x squared dx. dv is, what's left? 1 over x squared dx. So v would be minus 1 over x. Okay? Now, let's integrate by parts. So it'll be minus arctan x over x uv minus integral v du. There's a negative over there, so plus integral of 1 over x times 1 plus x squared dx. Now how do we solve this one? I believe we can do partial fraction decomposition. This one is a quadratic term, so you got to be careful. So we can write it as a over x plus bx plus c over x squared plus 1 is equal to 1 over x times x squared plus 1. Multiply both sides by this denominator, so a times x squared plus 1 plus parentheses, don't forget that when you write bx plus c times x is equal to 1. Okay, so we can do the plug-in number method. That's totally fine. I feel like whenever there's a quadratic term, the matching coefficient method is faster. So if you watch my partial fraction decomposition crash course, you'll know what I'm talking about. Okay, so I'm going to match coefficients. So I'm going to distribute everything out. It'll be a x squared plus a plus, over here will be a bx squared plus cx is equal to 1. Let's combine all like terms. So a x squared plus bx squared plus cx plus a is equal to 1. So I just moved all the square terms here, the first power terms here, and the constant terms here. Okay, so we can even write it like this. A plus b times x squared plus cx plus a is equal to 1. Okay, there's no x squared term on this side, so I know that a plus b is equal to 0. Similarly, there's no x term on the right-hand side, so I know c is equal to 0. And a is the constant is 1. So a is 1. So b would be negative 1, because a plus b is 0. We know a is 1, so b has to be negative 1. Okay, so we can rewrite our integral as, it'll be integral of a we said was 1, so 1 over x. B was negative 1, c is 0, so it'll be minus x over x squared plus 1 dx. Okay, and now this is easy to integrate. This is just ln. This is just also ln. You just have to do a little substitution in my head, or you could write it out, doesn't matter. Okay, I'm going to do it in my head. Okay, so plus ln of absolute value x minus, this should be minus half ln absolute value x squared plus 1. Let me double check by differentiating. I always do that. When I differentiate this, do I get back that? It'll be 1 over x squared plus 1, 1 over x squared plus 1 times 2x. So the 2 and this half would cancel, and we still have an x on top. Yes, good. Okay, plus c. That's my answer. So not too bad, actually. Just by parts, and then partial fraction decomposition. So two techniques needed, but it was not that bad, especially because the c was 0, so it made my life a lot easier. If c wasn't 0, it was not too bad either. This is just would be arctan. All right. Let me see if I can squeeze 43 on this page. Integral square root x over 1 plus x cubed dx. How would I go about this? Okay, so let's go down the list. As always, if you're in doubt. Can't do a substitution. I don't see an obvious one, but maybe we can hack it a little bit. So let's come back to that. And that's what I'll probably do. But let's keep going down the list. By parts, I don't see a product of two. There is a product of things, don't get me wrong, but not like one where I know it's integral very easily. Like I don't know the integral of 1 over 1 plus x cubed like that. So maybe not by parts. Maybe it's doable, but I'm going to try to avoid that. Not trig integral. Not trig sub, because I don't see something squared plus something squared. Well, technically this is a something squared. So maybe you can do a trig sub, actually. But the square root x would make it maybe hard. So maybe let's avoid that also. Rational function, it kind of is, but then the square root x makes it complicated. So, and then this is not, well, in the techniques you learn in at least using Math 2B, you don't know how to deal with a cubic. So we cross partial fraction decomposition out. Okay, so earlier I was saying maybe we can hack this x cubed, because if I want to substitute like u is square root x or something, that to try to like get rid of this, then we can hack this to make it look more like square root x also maybe. That's what I'm thinking. So let me rewrite it as integral square root x over 1 plus. How do we equivalently get x cubed by square x? Square x to what power gives me x cubed? Remember, x to the half is square root x. So if I say square root of x to the 6th power, remember, as I said, square root x is x to the half. When we have this guy to the 6th power, we can multiply the powers. So x to the half, so half times 6 is 3, so x cubed. So it's the same thing. Okay, so why in the world would I want to do this? Maybe let's let u be, so let me draw a line, u be square root of x. Okay, as always, we want to find du then, but remember we can square it to maybe make it nice, be nicer. U squared is x. So then 2u du is dx. Okay, so let's substitute. This guy is just u, dx is 2u du, up at the bottom is 1 plus, it would be u to the 6th. Okay, so we can write this as 2 integral u squared over 1 plus u to the 6th du. Okay, now I can hack it again by saying, so let's leave the top the same. We can say u to the 6th is u cubed squared. Why would I want to do that? I can make another substitution now. Maybe let's let v be our variable. V is u cubed. dv is 3u squared du. U squared du, I see the signature there. That's why I want to do that. So we get 2 over 3 integral. So this 1/3 came from here, because u squared du would be dv over 3. So I pulled the 3 out right away. Okay, so we would get, what did I say? dv over 1 plus v squared. Okay, does this look very familiar now? This should. This is arctangent. So it'll be 2/3 arctan v plus c. So 2/3 arctan, what is v? V is u cubed plus c. And then what is u? U is square root of x. So square root of x cubed plus c. And that's my answer. Okay, so here I just was comfortable with exponents and all that, so that I can make some algebraic manipulation or some hacks, if you want to call it a hack, to make some substitutions to make it look nicer, essentially. Okay, so you have to be comfortable with manipulating exponents in order to do that this way, obviously. Okay, as I said, there might be another way to do it. So if you were able to find a different way, great. But this seemed not too bad for me. It's like if I wanted to do by parts, it seems very complicated. So I kind of don't want to do that. Or even trig sub might be doable, but again, it looks very complicated. So this was not too bad in my opinion. Okay, so it's about 15 minutes, so I'll call it a part here. Hopefully this was helpful, especially for something like this. It was not very clear that you had to do some obscure substitutions, but it actually made the problem a lot easier after you were able to see it and manipulate it to be able to see it. Okay, so please like this video as always if you found it helpful. And please subscribe to the channel also if you haven't already. And hopefully I'll see you in the next video where I solve the next set of problems.